Right, in this video I am going to be using some pH paper, litmus paper I think it's called. I can test for both alkali and for acids. Now my objective is should de-ionized water be used for car radiators? Here's my new bottle of de-ionized water. I've got here real de-ionized water is made by passing water over charged resin, thus removing the ions. Now I've got some questions. The ones at the top I can do. For example, what's the pH level of de-ionized water straight out of a new bottle? Right, okay. So having some of the answers to some of my questions might be able to allow me to draw a conclusion. So I've got litmus paper and I'm just going to tear a couple of pieces off and then just I've got my litmus paper out of the way and my bottle of de-ionized water. So first test, what's the pH level of this water? And I've cleaned everything down. So look, it's a sealed bottle. I'm just going to pour that in there for now. But I'm going to pour some just in case that container's, well, I've cleaned it just in case it's ambiguous about its pH level. It's in the cap, right? Tear a bit off. Dip it in. So I've never done this experiment before, and straight away it should give us the result. So, I don't know if you can see that. I would put that in the 7. It's that one there. It's not that one, that's a bit darker, isn't it? It's sort of halfway between that one and that one. But is it next to the picture? No, I wouldn't even say it's halfway. I would say it is that one. pH is 7. Right. Okay, good. So we know pH of 7 is neutral. Next question, what's the pH level of de-ionized water left out to the atmosphere? I can't really answer that question right now because that's a fresh bottle. But what I can do is pour some into a separate bottle and test the pH level of it after a few. Even better still than that, I've just noticed that at the bottom of this bottle there is some de-ionized water that's been there for a long time. So me opening and closing the bottle, pouring things out, is the equivalent of having an aged bottle of de-ionized water. So is this de-ionized water, because de-ionized water is claimed to gain in acidity when it's exposed to the atmosphere. It gains acidity from the carbon dioxide because apparently, I'm not sure, but apparently so that it is ionizingly hungry. So I don't think so, but let's find out. So this is months and months old, maybe even like a year old de-ionized water. It's got I must admit it was closed, but at the end of the day it was only a tiny drop in, and there was enough air in there to, let's say, it's atmospheric, and there was only a tiny drop left. So let's have a look at that. Is it acidic? If it was acidic, it will be moving more towards orange kind of bit of the circle, and it is definitely not orange. I would say that this is again 7. It is 7. It's not that one. It is that one. It's not that one. So again it's pH 7. Do you agree? One last look. If you compare these two strips, they look exactly the same. That's the one from the pure, fresh out of the bottle distilled water, and that's the one that's aged in carbon dioxide atmosphere. So I don't think it's acidic. It hasn't picked up acidity. This is new litmus paper, or new universal indicator paper, I think it's called. I should really call it. I can't remember, it's a long time since I taught this subject. Anyway, let's get a number 7 in there. That's the pH level of de-ionised water left to the atmosphere, 7. What's the pH level of tap water? We'll do that kind of in a minute. We'll leave that one. What's electrical conductivity of new de-ionised water? Right. We can do 9-volt battery. It's a simple circuit. I should have something to kind of weigh the top of it down. You will notice on my voltmeter when I'm getting 9 volts, and this battery is actually quite old and goes to show it's quite good. So negative voltage or even positive, spot on 9. Negative 9 is fine, it means the same thing. Right, okay. So now we're getting voltage of that. Now, the reason why we're testing for electrical conductivity is because the definition of rust or oxidation is the kind of spiriting away of ions and adding electron here or taking an off electron there, and that's what happens to your metal in your car. If it's rusting, what's happening is you're gaining an oxygen, losing an electron, or gaining an electron, losing an oxygen. I can't remember, but let's find out. At 9 volts, if this water was electrically conductible, electrically conductible, I might get a bit of tape to kind of hold that one down, excuse me. There we go. Let's test it again. Should be getting 9 volts, and these two, here we are. Right, so if the water was electrically conductible, what would happen is it means it will allow rust. Now, the reason why I've always used in my head de-ionised water, which I think could even be distilled water, is because I'm thinking it will stop it from rusting. Okay, it will prevent it from rusting, because it's very difficult to pass electricity through de-ionised water. Because there's no ions, you need ions to electrically conduct. So here it is. Let me give you a close look at that. Switch my torch on. Is there any bubbles at all in any of those electrodes? You know, I can't remember. Is it the cathode would come up with hydrogen bubbles if it was electrically conducting? Right, I've got another idea. When I clean this off, when I stick the probe straight in the water, just about here where the jar is, with that side of it connected, and the other side connected to this, see if we get any voltage, see if it conducts electricity, in other words. I don't know, I'm not sure about this one. I'm not sure what the results will be. So here we go. It seems to conduct electricity, but not so well. 7.6 volts. That's interesting. So we're losing voltage over the water. It is conducting electricity. Alright, just had an idea. I wonder what the electrical conductivity of it will be after I put some ready mixed summer antifreeze in it. I wonder if this stuff will inhibit any kind of electrical conductivity. Let's have a look. Let's try that again. 0.3, so it's still conducting. Okay, tap water, diluted many times, another strip of universal testing paper, litmus paper. My guess is going to be exactly the same. 7. Or I'll be very worried about drinking anything that's not. Yeah. 7. Right. Let's try the bubble test. See if we can get any bubbles to come up. Using 9 volts. Don't let them touch. So that would be. It should be conducting electricity as it stands now, but how much? I don't know about you, but that one there is starting to bubble up. Do you see that? Minute bubbles are forming on that electrode. You know what? I'm going to run the other experiment again with the distilled water. Yeah? Because the ions, this will make sense. The iron in the water, the calcium and magnesium is moving around now, exchanging electrons here and there. Yes, it's definitely bubbling up. You see that? See that? That's why I don't use tap water. Number one, it's going to fur up your system when that stuff gets deposited in your radiator, and you can see it's happening right now. Electrically conducting, the ions are moving around and being deposited on one, and hydrogen is being liberated in the other, or they're both coming out of gas. I don't know exact formula what's going on right now, but something like that. Definitely that one bubbling up, this one's bubbling up. Definitely see it. You can even see the bubbles in it. Right, okay. Now, what we can do is to speed up that process. Now, someone said, actually, what? I can't. I tried to explain to him. I used to be a teacher of science, school science, right? It's in there again, right? I tried to explain to him. They're trying to convince me if you add. The reason why they don't use de-ionised water is because because the water has got no ions in it, like calcium, that will make the rusting process quicker. I thought, no way, what are you talking about? Watch what happens. Watch. If I add some table salt, I do recommend it because it's summertime coming up now. I do recommend more table salt in your diet. Watch what happens. It's not even. I'm not even like letting it dissolve or anything. Do you see that one on there? Do you see that one there? That one? See how it's actually, you can see a trail of bubbles coming up now? So adding salt to a liquid like water would increase the rate, as you'd expect, of rusting. It increases the electrical conductivity of the liquid. Ions from the salt are now moving around and depositing hydrogen on that one there, on the top one. You can see it. You can physically see it. It speeds it up, and the salt is hardly any salt there, and I've not even dissolved it. It's just salt and cold water. So I was going to pour some de-ionized water in this jar and test it again, just to show you. But we had it in there. We had it in there for minutes whilst I was faffing around with doing all sorts of other tests. Do you really want to see it again? Alright, okay. Clean that. Obviously that's tap water, so what I need to do is use my brake cleaner to clean it off. Clean off this tap water, and I'll dry it off. And I'll clean the electrodes with with brake cleaner. Okay. There we go again. and I'll do maybe like a time lapse on it. See that? Nothing. Nothing. A squeak of a bubble. See that? Nothing. Nothing at all. And in the same shot, I shall see if I can test. There we go, we've got voltage through there. It's voltage through the water, but it's not really conducting, so there's voltage. Voltage doesn't mean current. Alright. So with me testing one terminal and the other, there is a voltage going towards the terminal here and going towards the terminal there, because I've put a short between the two, and I'm using a multimeter to test it, right? Just because there's a voltage doesn't mean there's a current running through the water. There's a current running through the cables. If there was a current running through the water, what you'll see is you'll see bubbles coming up, right? Because that's the process of all these ions moving around. Right, that's the conducting aspect of what would be happening if you applied only 9 volts, right? Kind of close to a car voltage. So it would show a voltage because there is a voltage potential between the two cables. Kind of knocked down a bit because maybe the battery's losing power, or maybe it's getting lost in these electrical. No, it was 9, wasn't it? It was 9. So I'm not exactly sure why it's not reading 9 volts. When I take it out, it'll read 9 volts. Let me do that again. No, I was testing them. No, I was testing it properly. Oh, it is still 9. No, it is 9. So it is 9. However, if I take one out, put the other one in the water, it is 7. There is some sort of conducting going on, but not enough to produce any bubbles whatsoever. Alright, okay. I think I've kind of done this experiment to its nth degree for as far as what I can do. I would love to do like a ferrous metal in this de-ionised water and leave it for months, and likewise with tap water, and see what the results is. But there's no ions moving around. So come on. The conclusion that must be, it's better to use de-ionised water. And this is Halford's de-ionised water, probably about £5.99. In fact, I'm so confident I'm going to pour this straight back in there. I'm confident my experiment, I haven't contaminated the thing with anything. Alright, anyway, I hope this is like the go-to video for people who are unsure. So this is proof that de-ionised water is better than tap water for use in your car's radiator. And they say, oh, it leaks, it will scavenge the metals. When you're adding in the antifreeze, that's also a rust inhibitor. You've got rust inhibitor plus something that is very unlikely to rust, because it's pure, it's much purer, it's got no ions in it. Come on, okay. Can only be one logical conclusion if you're clever. If in fact, if it was really hungry and it took all the metal away from your car's radiator, right? If it really did do that, then I don't know then. Perhaps the only way I could test it is just suck some out from my radiator and test that, maybe. Alright, okay. That's exactly what I'm going to try and do then. Finale to this experiment. Don't let electrodes touch. Just sitting in there nicely. You know what? I don't see any bubbles at all. Could be wrong. I don't think so. We know there's 9 volts. And you know I always use de-ionised water. So if it was leaching metals from, I don't know, aluminium, the aluminium part of the engine block, or the cast iron, there would be ions in there now, which means it would conduct. Would be conducting electricity. It means it would be bubbling everywhere. Pinhole bubbles, bubbles escaping. Remember the tap water? How electrically conductive that was? How easy you can nothing on there. Nothing on there. Alright, that does it. Make sure I get that off. Right, okay. That's it. My radiator water's been sitting in there for months and months. It's not leached any metal into it. Otherwise we wouldn't know that. We could test that, because what happens, it would be fizzing away, because the ions in there would be kind of exchanging the electrons and would be liberating gas. So I was right all along. I don't mean to be like, you always have to have, in science you always have to have a scientific prediction. Have an idea of what's going on, test it, find out, make a conclusion. That's my conclusion. Use distilled water, use de-ionised water in your car's radiator in conjunction with ready mixed. If it's ready mixed antifreeze, then you don't have to bother, because they use this stuff anyway. If it's like from concentrate, then don't worry, just chug it in and look, stops your car's engine from rusting. Proof. Hit the like button, thumbs up, the bell, the icon. Leave a comment below. I know there's been a big argument on my channel about this, but this kind of proves me right, really.